Hey learners, welcome to Math. So learners, in this video we will see a problem based on subarray. So if you haven't seen our last video which was based on introduction of subarray, so I would recommend just go and watch this video. I will add that video in the I button and in the description and also in the comment box. So now just see. So if there is an array, so we have to find the sum of each and every subarray. Okay. So if there is an array, what is the total number of subarrays? I have taught it in the last video. It will be n into n plus 1 divided by 2. So n is what? The size of an array. So if an array is having 4 elements, so the total number of subarrays will be what? 4 into 5 by 2. So it will result in what? 10. Okay, so you can see then there are 10 subarrays. Okay, so subarray will start from what? From 0th index it can go to 0. From 0 to 0 the sum will be what? 1. From 0 to 1 the sum will be what? 1 plus 2 will be 3. From 0 to 2, from 0 to 2 the sum will be 1 plus 2 plus 1 plus minus 1 will be 2. From 0 to 3 the sum will be 1 plus 2 plus minus 1 plus 3 will be 5. So like this, from 1 to 1 the sum will be 2. From 1 to 2 the sum will be 2 plus minus 1 will be 1. So 1 to 3 will be 4. Like this, from 2 to 2 the sum will be minus 1. From 2 to 3 the sum will be 2, and 3 to 3 the sum will be 3. Okay, so how to get the set of sums for all the subarray? Okay, so if you know the solution for it, just comment out in the comment box. And now just proceed. So I have written a pseudocode over here, okay, which is taking an array. So n is the length of the array, and we are starting a loop over here which from I equals to 0 it will goes on to I n minus 1. Okay, so there is an inner loop for which will start from j is equals to y and it will goes on till j is equals to n minus 1. Okay, I am starting a sum with the value 0. Now there is another loop, inner loop, which is k will start from I and will goes on till j, and it is adding all the sum of elements and it will print the sum. So if you can see over here that the first the I will start from 0. Okay, then again the j is starting from I, so j is over here, and k is equals to I and will goes on to j. So k will run, this loop will run for one time, and the sum will be what? Sum is will be sum plus element of kth index. So the 0th index will be there, and it will be get added and it will be printed 1. So this loop ends now. So now j will become what? 1. So k will start from I, from 0, and it will add the element of 0th element to the sum, then it will add the element of 1th element to the sum, and then it will print the sum. So the sum of 1 plus 2, 3 will be printed. Similarly, the set of all subarray sums will be printed with this approach. Okay, so now what is the time complexity for it? This loop is there which will run for n times. This in the worst case will run for n times, and this also will run for n times in the worst case. So the time complexity will be what? Order of n cube. Okay, and what is the space complexity? So space complexity will be order of 1. because we are not declaring any extra array list like this. So the time complexity, as you can see, it is the order of NQ. So this is a last time complexity. So we have to think some way to reduce the time complexity from NQ, order of NQ. Okay, so now just see a solution for it, and if you know the solution, just comment in the comment box. So here's a question that can we optimize it? Yeah, we can. So just see the optimized solution. So here what we will do, we will just use a prefix sum. Okay, and instead of this inner loop over here, we'll use the prefix sum to get the sum of elements for a subarray. Okay, just see over here. Okay, so first we will assign the value of the 0th index element to the 0th index in the prefix sum, and we will just take a loop over here which will start from I equals to 1 and it will goes on to I n minus 1, and here we will calculating the prefix sum. Okay, so now with the help of a prefix sum we can just get the sum of the subarray. Okay, so you can see the loop is starting from I equals to 0 and it will goes on to n minus 1, and the inner loop is starting from j equals to I and it will goes on to n minus 1, and we are checking over here that if I is greater than 0, then we will just print the sum which we will get by subtracting the prefix sum of the jth index element minus prefix sum of I minus 1 index element. So in my previous videos I have taught about this prefix sum, the concept of prefix sum, and how to get the sum of elements from the starting to the ending index. Okay, so if you have to get the prefix sum between a set of elements, so we will do it by getting the element of the prefix sum of the right index minus getting the element of the L minus 1 index of the prefix sum if L is greater than 0, and L is over here what? I, and R is what? J. So we are just getting this with this equation, and else if L is equals to 0, then we will just print the value of the prefix sum of the rth index, right index. Okay, so the right index over here is j, so if the I is equals to 0, we will just print the prefix sum of the jth index. Okay, so now we can see the time complexity of it will be what? So for this it will run for n times, so this will be order of n, and this over here you can see that this will run for n times and this will also run for n times. So the time complexity will be what? The time complexity will be order of n plus n square, because this is running for n square times, so it will be order of n square only. So we have reduced the time complexity from previously it was order of n cube to n square, but you can see the space complexity, that space complexity is increasing because we are declaring a prefix summary. So with this the space complexity will increase and it will result in what? Order of n space complexity. So we have reduced the time complexity from order of n cube to n square, but we are increasing the space complexity from order of 1 to order of n. So is there any way in which we can reduce the space complexity as well? Just think about it, and if you know the solution, just comment in the comment box. So now just proceed. So can we optimize it more? Yes, we can. So if you can see that there is a method which is accepting an array, n is the length of the array, and Here the for loop will start from 0 and it will goes on to n minus 1. And so we are taking a variable sum. So far we are initiating with 0 and we are using the concept of carry forward. So if we don't know the concept of carry forward, I have taught it in the my previous videos. Okay, so I will add it in the I button and I also add it in the description. So just go through it. So now let's proceed up here. So if you are using the carry forward technique, so in the inner loop j will start from I and it will goes on to n minus 1. So here is an variable sum so far which will add the element of the jth index to itself, and here we are printing it here only. So for every element, such as if it starts from 0 and if j is equals to 0, it will the sum so far will add the 0th index element to itself and will print. So for the subarray from 0 to 0 will be printed. So when the value of j will be 1, it will add the element of the 1th index to itself and it will print the sum from 0th index to the 1th index elements, and it will and in the next loop it will print from the sum from the 0th element to the 2th element index. So with this we can just get the sum for each and every subarray. Okay, so and it will print the sum over here. So now, so what is the time complexity for it? So you can see that this loop is running for n times and the inner loop is running for n times. So the time complexity for it will be what? Will be order of n square, and the space complexity for it will be what? It will be what? Order of 1, because we are not taking any extra element. Okay, so with this we can get the optimized solution with the time complexity of order of n square and space complexity of order of 1, and we are reducing the space complexity with the help of carry forward technique. Okay, so learners, with this we get the optimized solution for it. So learners, this is it for this video. So if you like this video, just click the like button, do subscribe to our channel. We will be coming with more data structure videos, and in the next video we will be coming with a coding question which was asked in Google and Facebook and which was based on the subarray only. And do give it a feedback whatever you liked in this video. If you need to improve anything, just write it in the comment box. It will help us in improving our teaching lecture. And just hit the bell icon. Thank you.